Some real-world problems or applied problems involve geometry. These situations could cover a variety of problems. One of those are involving the area of a space. Remember that the area is measured two-dimensionally, meaning that the unit of measure is going to be to the second power. So think like square feet, square yards, square inches. So let's look at some problems. A rectangular parking lot measures 40 meters by 60 meters. There are two cars parked, each covering 2.5 meters by 5 meters. A small motorcycle takes up 1 meter by 2 meters, and a trapezoidal planer is placed in one corner. The trapezoid has a height of 1 meter, a base of 2 meters, and a top length of 1 meter. How many square meters of the parking lot remain unoccupied by vehicles and the planter? So there's a lot going on here, so we need to take it piece by piece. First off, let's just find out the total area of the parking lot, the entire thing, which is right here, 40 meters by 60 meters. So let's go with the parking lot. And the parking lot, since it is a rectangle, it should be area equals length times width. So that's the formula there. So it's going to be 40 by 60. And it doesn't matter which one's which, because multiplication can go both ways. 2 times 3, 3 times 2, still the same thing. So 40 times 60, 60 times 40, same thing. So when we multiply these two together, we're going to get 2,400. And since we're dealing with area, and the unit of measure is meters, it's going to be meters squared. So 2,400 square meters, or 2,400 meters squared. So that's the total area that we're working with. Next, we're going to go with the parked cars. So let's go parked cars. And we know we have two cars parked, and each are covering 2.5 meters by 5 meters. So they cover the same amount of area. So again, it's rectangular, because cars typically are more square, like that. So we're going to have 2, because 2 of the cars, times their area, which is 2.5 by 5. So again, length times width. So 2.5 times 5. And again, we just do all that, and we're going to end up with 25 square meters. A small motorcycle takes up 1 by 2 meters. So motorcycle. There's only one of those, and that's just going to be 1 by 2, which is very easy. It's just 2 square meters. And then the hard one here is the trapezoidal planter. So let's go with planter. And it's trapezoidal. So we have a specific formula for the area of a trapezoid, and that is 1/2 times the sum of the top and the bottom of the two lines that are parallel to each other in a trapezoid times its height. So right here it has a height of 1 meter, so that's good. So we know that h is 1. It has a base of 2 meters and a top length of 1. So those two are your A and B. So a base of 2, and get a little more space here, and a top length of 1. I guess it should be consistent. I'll put it as meters. So we know what A, B, and H are. So for the area of this, it's just going to be, let's see, 1/2, 2 plus, again, keep it consistent, 1 plus 2 times 1. And when you do all that, you're going to have an area of 1.5 square meters. So this is all the work. And now we can find how many square meters of the parking lot remain unoccupied by vehicles and the planter. So the area is going to be the total area of the entire parking lot, which is 2,400 minus the sum of each individual item within the parking lot. So the parked cars is 25, the motorcycle is 2, and the planter is 1.5. So we just run that through, and we're going to end up with 2,371.5 square meters. So that's how much area is encompassed in the parking lot when we remove the parking lot or the parked cars, the motorcycle, and the planter. Next, we have a right triangular garden that has a base of 15 feet and a height of 20. Inside at the right angle corner there is a shed with dimensions 2 meters by 3 meters, and there is a circular fountain with a radius of 1 meter that is placed inside the garden. How many square feet of the garden remain uncovered by the shed and the fountain? And you should know this little hint here that 1 meter is equal to 3.281 feet. So we know that we're dealing with certain things that are measured in feet and other things that are measured in meters. But again, very easy to deal with. So first off, let's get the total area of the garden, which is triangular. So we know that the area is 1/2 base times height. So we have a base of 15 and a height of 20. So that's easy to tell. So let's call it garden, which is going to be 1/2 base times height. And again, we run that through, and we're going to end up with 150 square feet of total space in the garden. Now we're going to move on to the shed. I guess this would be considered the hard part, which is not too difficult, actually. So we know that the shed has dimensions 2 meters by 3 meters, but we want our total answer to be in square feet, because that's what it says here. So we're going to convert our meters to feet first before we find the area, and you should do that first before you try any conversions later on, because those are different conversions. So 2 meters, and we're going to use dimensional analysis, can be converted to feet by using this fact of 1 meter equals 3.281 feet. So since I'm trying to get rid of meters, 1 meter goes in the bottom, while 3.281 feet goes up top. This way, algebraically, meters cancel, and we can just do 2 times the feet, which is going to give us 6.562 feet. I'm not going to round quite yet. So there's 2 meters to feet. Now we're going to do 3 meters to feet, which is the exact same process again, by which we want to make sure that our meters cancel and we're left with only the unit measurement of feet. So 3 times 3.281, which is going to give us 9.843 feet. So now we know what the length of the shed is in feet. So now we can find the area of the shed, and again this is a shed, we're assuming, because right here it says inside at the right angle corner, so it means it's going to be a square, or excuse me, a rectangle. So the area of this is going to be length times width, so we'll just call this the length, and we'll just call this the width. So 6.562 times 9.843, and when I get my area here, I'm going to get 64.59 square feet, and I'm rounding this to 2 decimal places. So this is the area of the shed. So we got the area of the garden, we got the area of the shed, and now all we got to do is get the area of the fountain. So it says that the radius of the fountain is 1 meter. Well, that's really nice, because that's very little work for us to do. So fountain, and since we're doing the circular fountain, the area of a circle is pi r squared. And we know that r is 1 meter, and we know that 1 meter is 3.281. So the area here is going to be pi times 3.281 squared. And again, multiplying that in, and I'm going to round to 2 decimal places because it's going to be an irrational number. It's going to give me 33.82 square feet. So now I have the total area of the garden, the total area of the shed, and the total area of the fountain, and I can find out how many square feet remain in the garden that's not covered by the shed or the fountain. So the area is going to be the total area, which is 150, minus the sum of the 2 smaller areas. 64.59 plus 33.82. And again, when we do the math, we're going to end up with a total area that's uncovered as 51.59 square feet. And zoom it all out so we can see the whole problem from top to bottom. And that is how you'd find the area that's uncovered in this specific question. So when you're dealing with area problems, typically you're going to try to find the whole area of the question, and then you're going to find the little bitty areas, the little small areas within it, and then you just subtract the total area, or I'm sorry, you take the total area and you just minus it from the little bits of area that you're removing from it.